In this video, let me show you how to do the crazy stuff with tangent lines, okay? You're gonna need a calculator. You're gonna need one of these clear rulers. You're also gonna need, to make the comparison that we talk about, you'll need to have your calculations of the position and the velocity and all that, okay? So here's the concept. What we're gonna try to do here is use tangent lines to find what the instantaneous velocity is at one of these points, okay? Now, this is a curved line. It's very hard to find the slope of a curved line. So what we're gonna do is we're gonna use the notion that a tangent line has the same slope as the curve at the point where it's tangent, if you draw it properly, okay? So let's pick 0.3 seconds. You can pick any time you want, right? 0.3 seconds looks good. And now I wanna get a line that's tangent right there. Now, tangent also means it's like parallel to it right there, okay? Now, this is gonna be tangent a little later. This guy's tangent a little earlier. But to me, that looks like it's just right, don't you think? So what you wanna do is you want to draw the line all the way across the graph. Now, at this point, if your graph doesn't have grid lines and if it doesn't have a right side, go back and make your graph have an actual right side to it. It has to have a plot frame and it has to have grid lines, okay? Now I'm gonna call this line A, just for fun, okay? And I'm gonna circle the endpoints of line A, okay? So there they are. And what I wanna do is I wanna read these points. I wanna get an ordered pair for these points. So this spot right here seems to be 0.150 over and 0 up. So literally I'm just reading where that point is on the graph, okay? And so this is my X, this is my Y. So read your graph, and if it's between, this one happens to hit that grid line, so I'm lucky. But if it's not on that grid line, read the graph as best you can. Okay, get as accurately as you can. And any division, you ought to be able to estimate 1/10 of that division. So let's look at this point. This point is over 0.450, but how far up is that? Well, let's see. Each one of these lines is 2, and so it looks like it's hitting it at 4, right? So that's going to be 84. Okay, so do your college best to read what that is. Now, what we're going to do is we're going to find the slope of this line. The slope of that line will be what the slope of this curved line is at 0.3 seconds. Of course, after that, it's more, and before that, it's less. But at 0.3 seconds, it'll be the slope of that straight line. So right on your graph, write line A. And what we're going to do, the general form here is the slope is y2, the second y minus the first y, over the second x minus the first x. And by first and second, I mean occurring in time, okay? Or occurring on the graph left to right, okay? So this is x1, y1. And then this is x2, y2. Okay, so now I'm just going to write this down here. So it's going to be y2 is 84, y1 is 0, so 84 minus 0, okay, divided by x2, which is 0.45, minus 0.150. So let's type that into my calculator. Now on these calculators, you can go alpha F1 and it'll let you do a fraction. So 84 minus 0.45 minus 0.15, and that's 280 centimeters per second. And notice that that is at 0.3 seconds, okay? Okay, so now what I want to do is I need to write a sentence comparing that to the velocity. So let's look at 0.3 seconds. There's 0.3 seconds, right? And I'm gonna draw wide. So this is 0.3, this is 0.283, this is 0.317. This number here that we just got, that 280, should be in that ballpark, right? So let's look, is 280 Yeah, well, it's 270, right? At 0.3, it's supposed to be 270, but right after that, it's 300. So the question is, did I draw it wrong? No, I'm going to stick by that. It should be 280, or 270, but it's 280. So I'm going to write a little sentence here. The slope of my tangent line A at 0.30 seconds was 280 centimeters per second. The values here range from 264 to 300, with 270 at 0.3 seconds. So we are pretty close. There we go. I actually was writing. You just can't read my handwriting. Okay. So you're gonna write a little sentence. Say what your slope of your line was at what time, right? And say what the values are there, and then just say, is it close or is it not close? Okay. All right. So let's do another one of these, right? So I'm going to do one at how about 0.2 seconds? We'll do 0.2 seconds. It should be less, right? Okay. So I'm going to put a dot at 0.2. I want to make this thing. I always try to get my head right above it. Okay. Let's see. Hold on. Okay. This camera is messing up my mojo. Okay, and I'm going to put boxes around these guys. Let me erase that. Okay, and a box around this guy. Okay, so what is this? This is 0.1. And then that would be 0.11. No, 0.101, 0.102, 0.103. No. 0.11, 0.12, 0.13, 0.14, 0.15. Okay, so it's between 0.11 and 0.10 and 0.11. So I'm going to say that it's 0.102. Okay, so it's 0.102 because it's just a little ways across. It's not right at that line, right? Maybe I'll say it's 3. I'm going to say it's 3. Okay. And then the y value is 0 because it's right on the x-axis, okay? So it's 0.103 over and 0 up. Let's look at this guy. This guy is 0.45 over because we're right on this x, this y, whatever that is, right? The plot frame. And then how far up are we? Let's see. We're closer to, it's like 60, is that 66? Not quite 66. This would be 65. 65, I'm going to go 65.5. Not quite 66. 65.5 is what I'm going to go with. All right. So read that as best you can, and I'm going to call that line B. And line B is going to be 65.5 minus 0, because that's what this guy here, right? 0. And then it's going to be 0.45, 0 minus 0.103, because I read that so accurately, right? All right, so 65, it's the rise of that thing over the run of that thing, right? So again, now I did that fancy fraction thing. If you don't have the fancy fraction thing, if you have a TI-83 calculator, no worries, you can go like this: 65.5 minus 0, right parenthesis, divided by left parenthesis 0.45 minus 0.103. Did I do that right? I feel like I did. 188.76. So I'm going to say it's 189 centimeters per second at 0.200 seconds. All right. So we got these 2 times. So let's look at 0.2 seconds. Let's see if our slope is close to 189. At 0.2 seconds, let's find it. Where's 0.2? There it is. Oh my God, look at this. I'm close. I'm actually much closer to 0.217 seconds. Okay, so notice that at 0.2 seconds, this thing says it should be 180, right? We got 189, so I'm going to write another sentence. The slope of line B at 0.2 seconds was 189 centimeters per second. The values here range from 162 to 192 with 180 at 0.2 seconds. So the line slope is a little high. There you go. So write a little sentence there. Say what you got for your for the slope of your tangent line. Say what the values are here and just compare them. You're a little high, you're a little low, you're right on the mark, you're in the ballpark. These are all things that we can say. So that's the deal, right? Is you're going to draw a couple tangent lines, compare the slopes of those tangent lines to the value in that table at that time. So this one was at 0.2 seconds. That's why we're looking at 0.2 seconds. All right. I hope that helps.